In this lesson, we're going to find the probability of continuous random variables using density curves. I want to remind you that the area beneath the density curve is equal to 1. Let's look at an example. A certain AP Stat teacher is feeling generous one day and decides that each student deserves some extra credit. The teacher assigns each student a random extra credit value between 0 to 5 and decimals included by using the random generator on the calculator. Let X, notice it's a capital letter, so this should stand out to you, as a random variable. Let X equal the amount of extra credit for a randomly selected student. The probability distribution, X, can be modeled by a uniform density curve on the interval from 0 to 5. Find the probability that a randomly selected student will get more than 3 extra credit points. So I would start by writing, since the variable has already been defined, saying what's the probability that X is greater than 3. And now I'm going to draw an image of what is described. We are told that the teacher assigns something between 0 to 5. And we know that the area under a density curve is equal to 1, and we're told it's uniform. That means every value would have the same probability of being selected. So if that's true, then it's going to form a rectangle. And we know again, as I said, that this area that's shaded in here would be equal to 1. So this horizontal axis has a length of 5 units, so that means that the height of this would have to be 1/5 or 0.2, because 5 times 1/5 would equal 1. And now we're asked, so what's the probability of getting 3, and here would be 3, or higher than 3? So that would be this green region in here. So how do I get that probability? Well, that would be equal to a length of 2 units times 1/5 would be 2/5, or 0.4. And now let's look at a probability example that you've really looked at before. We're told that the weights of 3-year-old females closely follow a normal distribution with a mean of 30.7 pounds and a standard deviation of 3.6 pounds. So it's approximately normal, where mu is 30.7 and sigma is 3.6. Again, we're making a probability distribution. It's a model, so we're using parameters. What's the probability that we have a female? So X is the weight, and the probability that she weighs at least 30 pounds, so that would be greater than or equal to 30. Well, I'm going to change this to the standard normal, where the mean is equal to 0 and the standard deviation is 1. So that means I need to find the corresponding z-score that corresponds to an x value of 30. So I need to do 30 minus the mean divided by the standard deviation, which is approximately 0.19. So I'm really looking for the area, make that negative 0.19. That is just a little bit larger, I should say the area to the right of negative 0.19. So glancing at this, I know my answer has to be greater than 50%, since the mean is at 0. So to get this probability, I can then do one of two things. I could go to table A, or I can use normal CDF on my calculator. So my lower value is negative 0.19. My upper, I put 9999. I'm just going many standard deviations greater. Mu in the standard normal is 0 and sigma is 1. And that produces a value of 0.57. So if we randomly select a 3-year-old, there is a 57% chance that she would weigh at least 30 pounds.